Hello everyone, today we are talking about the Neighbor Discovery Protocol, or ND for short, of IPv6. ND mainly implements communication on Ethernet networks by mapping IPv6 addresses as a network layer to MAC addresses as a data link layer. ND in IPv6 is similar to ARP in IPv4 and is implemented based on ICMPv6. As a key IPv6 protocol, ND provides the following functions: address resolution, duplicate address detection, router discovery, stateless auto-configuration, neighbor status tracking, prefix readdressing, and route redirection. ARP provides only address resolution and duplicate address detection. ARP is a stateless protocol that works as a data link layer and trusts all nodes on a line. Although ARP is efficient, it is insecure. An ARP device receives and caches all ARP reply and broadcast messages whose target MAC address is its own MAC address, without checking whether it has sent request messages or whether the reply messages are valid. Because of these features, ARP is vulnerable to the following common attacks. The first attack is a bogus gateway attack. For example, if an attacker forges a gateway address to send an ARP messages to a PC2, the ARP table on PC2 records an incorrect gateway address. As a result, the gateway cannot receive data from PC2. This is a more serious ARP attack. If an attacker sends ARP broadcast messages, the entire line may go offline. The second attack is a gateway spoofing attack. For example, if an attacker forges a PC2 address to send an ARP message to the gateway, the ARP table on the gateway records an incorrect PC2 address. As a result, PC2 cannot receive data from the gateway. The third attack is a user spoofing attack. For example, if an attacker forges an PC1 address to send an ARP messages to PC2, the ARP table on PC2 records an incorrect PC1 address. As a result, PC1 cannot receive data from PC2. The fourth attack is an ARP flood attack. In one version of this attack, an attacker forges a large number of ARP messages with varying source IP addresses to overflow the ARP tables. As a result, valid ARP entries cannot be generated for ARP messages of authorized users, interrupting communication. In another version, an attacker sends a large number of ARP messages with unresolvable target IP addresses to the device. The device therefore repeatedly resolves these addresses, overloading the CPU and affecting communication. In ND, address resolution is implemented at layer 3. As such, the standard layer 3 security authentic mechanism can be used to prevent certain ARP attacks. IPv6 address resolution uses layer 3 multicast addressing to limit the transmission group of message and provide broadcast attacks. That means that certain common ARP attacks do not exist on IPv6 networks. However, ND is still susceptible to following attacks, but we have mature solutions to counteract them. The first attack is an address spoofing attack. For example, an attacker forges the IP address of a legitimate user to send NS and ARS messages, which will modify the ND entries on the gateway or of the legitimate user. As a result, this user cannot receive messages. If an attacker intercepts the messages of a legitimate user, the attacker can illegally obtain the user's data. To defend against such attacks, we can deploy ND snooping on the switch, configure the interface connected to the authorized router as a trusted one, and enable ND message validate check on the user-side interface. Invalid messages are directly discarded to prevent the damage caused by the forged NA, NS, RS messages. The second attack is an RA attack. For example, if an attacker sends a forged RA messages, the following attacks may occur. First, the attacker forges a non-existent prefix to modify the routing table of the attacked host. Second, the attacker forges the MAC address and the lifetime of the gateway to change the default gateway of the attacked host. Third, the attacker forges a DHCP server address and the M bit in an RA message so that the attacked host uses a forged IP address allocated by the bogus DHCP server. We can also deploy ND snooping on the switch and configure the interface connected to the authorized router as a trusted one. In this case, the switch discards RA messages received from the untrusted interface and processes only RA messages received from the trusted interface. This prevents RA attacks. Okay, let's summarize what we have discussed so far. In terms of functions, ND supports router discovery, stateless auto-configuration, neighbor status tracking, prefix readdressing, and route redirection compared to ARP. In terms of security, ND removes some ARP attacks and prevents broadcast attacks. With ND snooping enabled, ND is much more secure than ARP. Alright, that's all for today. Thank you so much for watching.